Hey everybody, this is Larry. This is me doing a bi-weekly contest 100 Q2. Maximize greatest of an array. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about this problem. So this one, it's a little bit weird in that, I mean, I'm not saying that this is a hard problem, but I feel like there's more thinking and more logical steps behind this problem versus Q3. So I'm a little bit weird about the timing. I mean, I guess they're worth the same points, but it's still a little bit weird, even though, like, they're in the same area, and I'm not saying this one is hard, but it is a little bit of an awkward Q2. So yeah, so this one, I think the first observation is that you're permutating the array, right? The input. So the key thing to note about this is that when you permutate when you permutate, so the idea behind this one is that you're trying to find a permutation of the input such that, you have this condition, right? But then, and the idea is that the equivalent question is that, let me write it out a little bit. This is already spoilery. But basically the idea is that, let's say you have this one, right? The answer for this, the best answer for this one is this best answer that goes into something like this, right? And this is just disordered, of course. And the reason why this is the case is because if there's a permutation, let's say this one that they give in the example, if there's this one, then there is an equivalent answer that just maps. So if there's something that maps, this array into this permutation, which is a sorted permutation, it should also map this one into the equivalent of the sorted one. So therefore, the first idea is that you can sort the input, right? And then after you sort the input, then it becomes just greedy, because then now for each number you just return the next number that is bigger than it, right? And if you go from smallest to the largest, and I guess technically you don't need to do it this way, but the way that I think, yeah, I mean, you'll see in a second. But the idea is that if you process the number from small to big, you're always going to process the smallest number, and in a greedy way, that means that if you there are only two choices, right? If you don't choose this number, if you choose a smaller number, well, you can choose a small number because by definition you already chose the smallest number. If you choose a bigger number, it can only lead to a more suboptimal matching because you may be using a number that could be matched two other numbers or something like this, right? Some kind of exchange argument. So that's basically the idea, and that's basically the implementation. So first I sort the array, I set n, and then count as the answer. And then basically what I do is just that I do a two-pointer algorithm, and then I just keep on trying to find the next number that is bigger than the current number, and that would match it. So that's basically the idea, and this is of course n log n time, and O of n space, because of the sorting that we do, because you should probably make a copy. Yeah, but this is 2 pointers, and the rest of the code runs pretty fast as a result. So fast that if you watch during the contest, I actually submitted with the print statement by accident, and it still was fast enough. So thank goodness. But yeah, that's all I have for this one. Let me know what you think, and you could watch me solve it live during the contest now. In the worst Q1 of my life. Alright. I had the ideas, but it was just a mess. Okay, let's read it. Number of indexes in which perm sub I is greater than num sub I. Okay. How far am I behind? People are very quick. And I have so many wrong answers. Oh, whoops. Really? Where's end? I didn't consider the offset case. Okay, fine. Oh, that they're not unique. I guess if they doesn't make sense if they whatever. But okay, at least I got that one right. So far behind. Yeah, thanks for watching. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about this problem. Yeah, stay good, stay healthy to good mental health. I'll see y'all later and take care. Bye bye.